Assalamualaikum and good day. You are with me again, Miss Huda. Let's do the center of gravity. Example number 3. Find the location of center of gravity from point P here and reaction at support A and B. The information given, the wall thickness is 150 mm and the density of brick wall is equal to 2000 kg per meter cube. These two information is needed for us to calculate the reaction at support A and B later on. Let's do the center of gravity first. The wall here, it combines a few shapes that we need to divide it into sections supaya senang kita nak calculate. Because of this triangle is actually sama sisi, ini sama dua. Jadi kalau kita tak bahagikan kepada dua, we make it as one big triangle pun boleh juga. Tapi in this case, saya bagi kepada dua. You can try to do it as one big triangle. So make it this one as one. The triangle, I divide it. So section 1, 2, 3 as the one big rectangle. And the quarter circle as section number 4. And another one is the hollow round section here as number 5. The point P, I put the x-axis and y-axis. Supaya senang kita nak dapatkan the distance from the point. So that kita pakai axis ni untuk dapatkan the distance from the centroid. As per example 1 and 2, we're going to do the table to get the centroid. For the first area, which is the triangle yang kita bahagi dua, the area yang kita akan kira adalah setengah darab. Ini kita agak-agak lah ya. This is 1 meter. This is 2 meter. So definitely this figure tak lengkap sangat dia punya dimensions. So I put here 1/2 times 2 meter, the width, and the height is 6 meter. That is for the area. And the distance from the centroid means kita nak cari x bar. Distance centroid number 1 to x-axis, which is this is the value. For triangle, we have to understand that bawah ni 1/3 H, atas ini 2/3 H, 1/3 B, 2/3 B. Kalau dia pusing macam mana sekalipun, ini rules dia. Dan distance itu sampai ke mana. Kalau dalam case kita, kita nak sampai x-axis. So, ini 1/3 H tambah lagi dengan another 3 meter to reach x-axis. Therefore, for x bar, it will be 1/3 times with the height of the triangle, 6 meter, plus with 3 meter. This is the answer that I put in the table. Next, we do for the y bar. For y bar, the centroid masih kat sini juga. Then we need the distance to y-axis. Then you know here it should be 2/3 times B. And here we have another 3 meter. Therefore, y bar is equal to 2/3 times 2 meter plus with 3 meter. And here is my answer. Then we need to find the AX bar by multiplying the area with the x bar and ay bar by multiplying the area with y bar. For the triangle number 2, the area sama je dengan triangle number 1. The B sama 2 meter and the height is 6 meter. For the x bar pun sama juga macam the first triangle sebab distance-nya sama. Ya, di sini adalah 1/3 H dan you have balance dekat sini kena tambah 3 meter. So, x bar-nya adalah 1/3 times 6 meter plus with 3 meter. Similar ya dengan my answer here. For y bar, the distance will be from the centroid to the y-axis. So, what you need to find is berapa distance dari centroid of the triangle ni sampai hujung sini. And balance dekat sini adalah 5 meter ya. Campurkan semua ni. So, ini dia adalah 1/3. Ya, sebab dia lebih ke kiri. Kita boleh agak sebenarnya untuk triangle. Times with lebar triangle ni adalah 2 meter. And plus with 5 meter. That is for the y bar, which is shown here. And the same process for the x bar and ay bar, you can calculate yourself. For section 3, it is a rectangle. The width is 10 meter and the height is 3 meter. So the area is 10 meter times 3 meter. Next, we need to find the x bar. So distance from the centroid of the rectangle to the x-axis. Therefore, 3 meter divide with 2. And for y bar, it will be from the centroid to the y-axis, which is 10 meter bahagi 2. This is the one yang saya tulis dekat depan. And get the ax bar and ay bar in the same manner. For section number 4, this is quarter circle. The area for quarter circle is pi r square divide with 4. As you know, satu bulatan ni area dia pi r square. So kalau quarter you bahagilah dengan 4. So you kira the area. So pi times 3 meter power of 2 divide with 4. That is the area. For the x bar, distance from the centroid of the quarter circle to x-axis. Formula untuk quarter circle x bar adalah 4r bahagi dengan 3 pi. So 4 darab the radius which is 3 meter divide with 3 pi. So tak ada lagi any distance yang we have to add because of dah sampai x-axis. And for the y bar, sama juga. Ini pun adalah 4r bahagi 3 pi. So 4 times 3 meter divide with 3 pi. However, you have to plus lagi dengan distance nak ke y-axis, which is you have another 10 meter. This is as what I shown dekat depan. Get the value of ax bar and ay bar. And last kali we have the hollow section, which is the circle. For this circle, we need to get the area, which is for circle, it is pi r square. So pi times 1.5 meter power of 2. And the distance from the centroid to get to the x-axis adalah 1.5 meter. Ataupun you boleh juga tulis 3 meter bahagi 2. And for y bar, it would be 3 meter divided with 2. Distance dari centroid nak ke y-axis here. So 3 meter divided with 2 sampai sini saja. This is 3 meter divided with 2. And you have another 4 meter. So you have to plus 4 meter. So inilah yang saya tulis. Next, you calculate the AX bar and AY bar for section number 5. We must remember that this is the hollow section, means you have to minus the value. Yang lain semua tambah. So you ambil the area, tambah, minus. You get 42. And for the AX bar pun sama, tambah, minus. This is the value. And 26 plus 34 plus 150 plus this one minus 38.88. You will get 250.809. Next, we can calculate the AX bar and Y bar from the value of total yang kita dapat kat bawah ni. Just use the formula for X bar, which is total area X bar divided with total area. So the total AX bar we have as what we calculated here and divide it with total area, which is 42. You get 2.462 meter from x-axis. And for Y bar, take the value of 250.809. That is from the formula, which is total area Y bar divide with total area. And bahagikan lagi dengan total area, you will get 5.972 meter from y-axis. What we need to do next, bila kita dah dapat the centroid, then we can finally get the reaction of RA and RB. But first, kita hanya ada area of the wall, but we still don't have the value berapa weight of the wall tu. We can calculate the volume of the wall first. Ambil saja area of the wall daripada table kita tadi and times with the thickness of the wall given in the question. You will get 6.3 meter cube. And from the volume of the wall, we can calculate the weight, take the volume and times with the density of the brick wall, which is 2000 kg per meter cube. This one given in the question. Bila you darab, you akan dapat dalam kilogram. Kilogram adalah mass. So we don't want the value of mass. What we want is dalam berat, which is Newton ataupun kilonewton lah. So kita kena darab dengan gravity acceleration 10 meter per second power of 2. Then you will get 12,600 kilogram meter per second power of 2. Ataupun ini adalah bersamaan dengan Newton. Dan boleh tukar kepada kilonewton bahagi dengan 1000. You will get 126 kilonewton. We have to mark where exactly the centroid yang kita kira tadi so that lebih senang untuk dapatkan the reaction at A and B. So, the most important untuk dapatkan reaction is the distance ke y-axis which is y bar. The distance to x-axis ni actually kita tak pakai, but because of the question minta you cari the centroid, then you have to find it lah. So sekarang kita boleh start cari the reaction at RA ataupun RB. So we can take the moment dekat mana-mana point of reaction yang you nak. And for this example, I take the moment at B. So it is equal to 0 because of equilibrium. What we have is, sebab kita dah ambil dekat point B, so I start with the first force yang kita ada, which is reaction ya. So reaction going to be, it will be RA darab dengan distance to B. It is 3 plus 1 plus 3 plus 3 plus 3. 13 meter. Plus ya. Sebab dia arah jam. Next we have is 10 kilonewton per meter. This is the beam. Going to be counterclockwise. So minus 10 kilonewton per meter times the length of the beam. Sebab ini adalah UDL, kita kena darab dulu dengan length of the beam. 13 meter. And the distance from centroid to B, 6.5 meter. So, separuh daripada panjang beam. Dan force terakhir yang kita ada is the weight of the wall, which is 126 kilonewton per meter counterclockwise. And the distance from the centroid of the wall to B should be, sebab kita ada centroid dia adalah 5.972 daripada y-axis. So, we must minuskan distance from y-axis to B adalah 13 meter. So, kita kena ambil 13 meter, tolak dengan 5.972 meter dan baru kita akan dapat value berapa sebenarnya distance from the centroid of the wall to B. Bila dah tak ada lagi force, then it is equal to 0 because of equilibrium. As shown in this calculation, the value of 7.028 meter come from 13 meter minus 5.972 meter. Next, we will simplify the moment equation here and we will get the value of RA is equal to 133.118 kilonewton. Next, we're going to calculate for the force equation. So, total force arah Y is equal to 0, which means equilibrium. Then, let's do the force equation. First, we have the RA, which is kita dah ada because kita dah dapat masa kita kira moment equation. RA going up and the value memang positif tadi. Kita kira pun kita dapat RA value dia positif. So, betul lah the assumption here that RA naik ke atas. Next, we have 10 kilonewton per meter. The loading that come from the beam. And ini adalah UDL. So, dia turun 10 kilonewton per meter for exactly 13 meter length of the beam. Turun ke bawah, loading 10 kilonewton per meter darab dengan 13 meter. And kita ada juga loading that come from the wall, which is 126 kilonewton turun ke bawah. So, minus 126 kilonewton. And last kali we have the RB. So, the assumption is RB naik atas. So, plus equal to 0. Ini adalah yang saya dah tulis. Exactly the same. And value of RA kita replacekan lah because kita dah ada inside the force equation. And we can find the value of RB. We get 122.882 kilonewton. That is the value of reaction at A and B. I'll see you again in the next video. Thank you so much and have a nice day. Bye.